Hello, let's talk about proving trigonometric identities. To prove a trigonometric identity, we have to show that we can change the expression on one side or on both sides so that both sides look identical. Let's see what we need to do to prove trigonometric identities. Usually we start with the side that looks more complicated and we simplify it so that it looks identical to the other side. In some cases, we may want to simplify both sides simultaneously. Now, let's start with the first example. Cosecant of x times tangent of x equals secant of x. In this identity, the left side looks more complicated, so we will start by simplifying this side. One simple technique that often works is to rewrite each trigonometric expression in terms of sines and cosines. So, using the fundamental trigonometric identities to the left, we will write cosecant of x as 1 over sine of x and tangent of x as sine of x over cosine of x. So again, in place of cosecant of x, we will write 1 over sine of x, and in place of tangent of x, we will write sine of x over cosine of x. Then the right side is secant of x. Now on the left side, sine will cancel, and we will have 1 over cosine of x equals secant of x. But then 1 over cosine of x is secant of x. And now the left side is secant of x, and the right side is secant of x. So we just proved that the left side is equal to the right side. Now in the second example we have sine of x equals cosecant of x minus cosine squared of x times cosecant of x. In this identity, as you see, the right side looks more complicated. I want to show you two different methods you can use to prove this identity. With the first method, notice that on the right side we have two terms and both of them have cosecant of x, so let's factor it out. Then we will have sine of x equals cosecant of x, parenthesis 1 minus cosine squared of x. Now let's take a look at the first Pythagorean identity. This is sine squared of x plus cosine squared of x equals 1. In this identity, if we take 1 and we subtract cosine squared of x, then we will get sine squared of x. So then we will replace 1 minus cosine squared of x with sine squared of x. Then on the left side we will have sine of x, and on the right side we will have cosecant of x times sine squared of x. In the next step, we will replace cosecant of x with 1 over sine of x. Then we will have sine of x equals 1 over sine of x multiplied by sine squared of x. Then on the right side, sine squared of x divided by sine of x is sine of x. Then we will write that sine of x equals sine of x. So we just proved that both sides are identical. But now let's see the second method. With this method, let's rewrite each cosecant of x as 1 over sine of x. Then we will have sine of x equals 1 over sine of x minus cosine squared of x times 1 over sine of x. This is the same as sine of x equals 1 over sine of x minus cosine squared of x over sine of x. Now, once we have two fractions with the same denominator, we can subtract and write them as a single fraction. Then we will have sine of x equals 1 minus cosine squared of x over sine of x. Then here we know that 1 minus cosine squared of x is sine squared of x. Then we will write that sine of x equals sine squared of x over sine of x. Then on the right side, sine squared of x divided by sine of x is sine of x. Then we will have that sine of x equals sine of x. So again, we proved that both sides are identical. Now, in the last example, we have the identity cosine cubed of x over cotangent of x plus 1 over cosecant cubed of x equals sine of x. The right side is just sine of x, so we will work on simplifying the left side. In the first step, I will rewrite this expression as cosine cubed of x times 1 over cotangent of x plus 1 over cosecant cubed of x equals sine of x. Then in the next step, I will replace 1 over cotangent of x with tangent of x. So we will have cosine cubed of x times tangent of x plus 1 over cosecant cubed of x equals sine of x. Next, I will rewrite all the functions in terms of sines and cosines. For this, I will replace tangent with sine over cosine and 1 over cosecant cubed of x with sine cubed of x. Then we will have cosine cubed of x times sine of x over cosine of x plus sine cubed of x equals sine of x. Now on the left side, cosine cubed of x divided by cosine of x is cosine squared of x. Then we will have cosine squared of x times sine of x plus sine cubed of x equals sine of x. Now on the left side we have two terms and they both have sine of x. So let's factor it out. Then we will have sine of x parenthesis cosine squared of x plus sine squared of x equals sine of x. Then according to the first Pythagorean identity, sine squared of x plus cosine squared of x equals 1. So the expression inside the parenthesis is 1. And now we have sine of x equals sine of x. So we just proved that the left side is identical to the right side. Now I wish you a nice day and thank you for watching.